My dear students, welcome back to our channel. Students, in this video, I am explaining JNTUH Hyderabad MBA third semester subject Production and Operations Management important questions one by one. Let's start with first one. Definition of production. Production refers to the process of converting raw materials, labor, and other resources into goods and services that have value. It is the process of creating output from inputs, with the ultimate goal of satisfying human needs and wants. Production is a central activity in economics, businesses, and industries, and it plays a crucial role in determining the availability of goods and services in an economy. Example of production: manufacturing of cars. Process: the workers in a car factory use machinery and raw materials like steel, rubber, and plastic to assemble the components of a car. Each part is manufactured, then assembled, and finally tested to ensure the car is functional and safe. Output: the final product is a completed car, ready to be sold to consumers. This is the result of the production process. Value: the car produced satisfies the needs of consumers who wish to purchase a vehicle for personal or business use. In this example, production is the entire process of creating a car by combining various factors of production, transforming raw materials into a finished good that has value in the marketplace. In summary, production is the process through which goods and services are created to satisfy the needs and wants of consumers. It requires the combination of resources, labor, capital, and entrepreneurship to generate valuable products, and it is a key driver of economic growth and development. Next important question is definition of generic strategies. Generic strategies are broad approaches or plans that businesses use to achieve a competitive advantage in their industry. These strategies focus on different ways a company can position itself in the market to outperform its competitors. The concept of generic strategies was introduced by Michael Porter, a professor at Harvard Business School, in his book Competitive Strategy: Techniques for Analyzing Industries and Competitors, 1980. Porter identified three primary generic strategies that companies can use to achieve a competitive advantage. 1. Cost leadership. 2. Differentiation. 3. Focus. Each of these strategies aims to help a company gain an edge over competitors, either by lowering costs, offering unique products, or targeting specific market segments. Next important question is generic strategies' significant impact on the production management function. Generic strategies have a significant impact on the production management function of a business. The production management function involves planning, organizing, directing, and controlling the production process to ensure that goods and services are produced efficiently and meet quality standards. Depending on the chosen generic strategy, cost leadership, differentiation, or focus, companies adjust their production processes in various ways to align with their strategic objectives. Here's how each generic strategy impacts production management. 1. Cost leadership strategy. Objective: to produce goods or services at the lowest possible cost while maintaining acceptable quality. Example: Walmart. Walmart's cost leadership strategy relies on its ability to produce and distribute goods at low costs. In production management, this means that Walmart focuses on high-volume, low-cost suppliers, efficient logistics, and maintaining low inventory costs through just-in-time (JIT) practices. The production process is focused on maintaining high efficiency and low operating costs to pass savings on to consumers. 2. Differentiation strategy. Objective: to offer unique products or services that stand out from competitors and can command a premium price. Example: Apple's differentiation strategy focuses on creating innovative and high-quality products like the iPhone, iPad, and MacBook. In production management, Apple emphasizes precise and high-quality manufacturing processes using advanced technology and high-end materials. The production process is designed to ensure that every product meets the company's premium standards, and flexibility is incorporated to accommodate new design features. Apple's production teams work closely with R&D to ensure that product features are consistently delivered with high quality. 3. Focus strategy. Objective: to concentrate on a specific market segment or niche, either through cost leadership or differentiation. Example: Rolls-Royce differentiation focus. Rolls-Royce focuses on the luxury car market, offering highly customized, premium vehicles. Production management needs to be highly specialized to ensure the car meets the exact specifications of wealthy customers. This includes using skilled labor, high-end materials, and incorporating detailed craftsmanship into each vehicle. The production process is flexible and responsive to specific customer demands, such as custom design features and premium finishes. IKEA cost focus. IKEA's focus is on providing affordable furniture to customers, often through flat-pack designs. Production management focuses on high efficiency, low-cost manufacturing, and maintaining economies of scale within the niche market of budget-conscious consumers. This involves mass production of standardized products, efficient supply chain management, and minimizing waste, while still appealing to the specific needs of its market segment. In conclusion, the choice of generic strategy directly influences how production is managed. Cost leadership requires efficient, high-volume production with a focus on minimizing costs. Differentiation involves quality, innovation, and flexibility in the production process to meet unique customer needs. Focus strategies require specialized production to serve niche markets, either by offering lower costs or highly differentiated products. Next important question is: functional strategies refer to specific actions and plans developed by various departments or functions within an organization to support the overall business strategy. These strategies are designed to optimize the performance of individual functions, such as marketing, finance, operations, human resources, etc., and ensure they contribute to achieving the broader goals of the organization. Each functional area needs to align its strategies with the company's overall objectives and the business environment to create value and gain a competitive advantage. Here are the main elements of functional strategies, explained with examples. 1. Marketing strategy. Definition: the marketing strategy focuses on how a company will promote and sell its products or services to customers. It includes decisions about product development, pricing, distribution, and promotional activities. Example: Apple's marketing strategy revolves around differentiation and premium pricing. It targets high-income customers who value innovation, design, and quality. Through strong brand positioning, Apple creates an image of exclusivity and premium quality. They focus on product development, example, iPhone, iPad, high-quality advertising, and selective distribution through their Apple stores and high-end retailers. 2. Financial strategy. Definition: financial strategy deals with how a company plans to manage its financial resources to achieve its goals. It includes decisions on funding, capital structure, investments, and risk management. Example: Tesla uses a financial strategy focused on securing funding for innovation and growth. The company has raised significant capital through both debt and equity, allowing it to invest in large-scale projects like gigafactories and the development of electric vehicles. Tesla also manages cash flow carefully to fund its ambitious expansion plans while controlling costs through production efficiency. 3. Operations strategy. Definition: the operations strategy involves planning and managing the processes involved in producing goods and services. It focuses on maximizing efficiency, quality, and customer satisfaction. Example: Toyota is known for its lean manufacturing system, which focuses on eliminating waste, such as excess inventory or time delays, while improving quality. The company has optimized its production processes using just-in-time (JIT) inventory management, making the entire supply chain more efficient and reducing production costs. This operational efficiency supports Toyota's strategy of cost leadership. 4. Human resources (HR) strategy. Definition: HR strategy focuses on how the organization will manage and develop its workforce to align with the company's overall goals. It includes recruitment, training, development, and retention of employees. Example: Google's HR strategy is centered around hiring top talent and fostering a creative, innovative work environment. The company offers extensive training and development programs, employee benefits, and an open, collaborative culture. Google also focuses on performance management by setting clear goals and giving employees the autonomy to innovate, which helps retain high performers and maintain company culture. 5. Research and development (R&D) strategy. Definition: the R&D strategy focuses on how a company will invest in and manage innovation to develop new products or improve existing ones. Example: pharmaceutical companies. Example: Pfizer's R&D strategy focuses on developing new medicines, vaccines, and therapies. The company invests heavily in research to address global health issues, including the COVID-19 vaccine. Their R&D team works in collaboration with governments, universities, and other healthcare organizations to advance medical science and bring innovative treatments to market. 6. IT strategy. Definition: the IT strategy focuses on how technology can be used to support and improve business processes, systems, and decision-making. Example: Amazon's IT strategy is built around technology that drives its logistics, e-commerce platform, and cloud computing services. The company has invested heavily in data analytics to personalize shopping experiences for customers. Amazon Web Services, AWS, its cloud computing arm, also plays a key role in generating revenue and enabling digital innovation for businesses worldwide. 7. Sales strategy. Definition: sales strategy focuses on how the company will sell its products or services and manage relationships with customers. Example: Microsoft uses a sales strategy that combines direct sales through its account managers, online sales for smaller customers, and a network of resellers and distributors. They also focus on maintaining strong relationships with enterprise clients, offering customized solutions and ongoing customer support. In conclusion, functional strategies are crucial for ensuring that each department or function in an organization works in harmony to support the overall business objectives. These strategies help companies optimize their operations, gain competitive advantages, and achieve long-term success. Next important question is: discuss different steps involved in product design with suitable examples. Product design is a multi-step process that involves creating a new product or improving an existing one. The process aims to meet customer needs, solve specific problems, and ensure the product is functional, manufacturable, and marketable. The steps in product design may vary depending on the nature of the product, the industry, and the company's specific approach, but typically include the following. 1. Idea generation, conceptualization. Objective. This phase involves generating a wide range of ideas and concepts for a new product or a product improvement. The focus is on creativity and innovation to find potential solutions to a problem or to meet an unmet need in the market. Example, a company might generate ideas for new smartphone features such as better battery life or improved camera quality. The product design team may also explore how to integrate new technologies like augmented reality (AR) into the phone. 2. Concept development. Objective. In this phase, the best ideas from the idea generation stage are turned into more detailed product concepts. These concepts are refined and analyzed to ensure they can realistically meet the goals established earlier, such as functionality, cost, and manufacturability. Example, for the smartphone, the design team might develop multiple concepts for new camera designs. One concept could focus on integrating a larger sensor, while another might focus on a unique lens arrangement for better zoom capabilities. The team would evaluate each design's technical viability, ease of production, and how it appeals to consumers. 3. Detailed design and engineering. Objective. This phase involves creating the detailed specifications for the product. All design elements, from material selection to manufacturing processes, are carefully planned and documented. This phase is also when prototypes are created and tested. Example, in the smartphone design process, engineers would finalize the material selection for the casing, example, aluminum, plastic, or glass, and the components, example, battery type, screen technology. They would also build and test prototypes of the phone to check factors such as durability, battery life, and screen resolution. 4. Prototype development and testing. Objective. During this phase, working prototypes of the product are created, allowing the team to test its functionality, ergonomics, usability, and durability. Feedback from prototypes can lead to design improvements. Example, a team may produce an initial prototype of the smartphone, allowing users to test features such as the interface, battery performance, and comfort when holding the device. The testing might reveal that the phone is too heavy or the touch sensitivity needs improvement, prompting design changes. 5. Design refinement and iteration. Objective. Based on prototype testing and feedback, the design is refined and optimized. The goal is to address any issues or improvements identified during testing and ensure that the product is ready for manufacturing. Example, if testing reveals that the smartphone's screen is prone to cracking, the design team may switch to a more durable glass material. They may also improve the user interface based on user feedback, making it more intuitive and user-friendly. 6. Manufacturing and production planning. Objective. This phase involves preparing for mass production. The design is finalized, and the manufacturing processes are set up to produce the product efficiently and at scale. Example, the smartphone's design is now ready for mass production, so the company starts sourcing components from suppliers, such as chips, screens, and batteries. They also set up the assembly line, test it with a small batch of smartphones, and make adjustments if necessary. 7. Market launch and distribution. Objective. This phase involves launching the product into the market and ensuring it reaches the intended customers. It focuses on promotion, sales channels, and after-sales service. Key activities: developing marketing strategies and campaigns to promote the product. Coordinating with distribution partners, example, retailers, online stores. Ensuring after-sales support, including customer service and warranties. Gathering customer feedback post-launch for continuous improvement. Example, the smartphone is launched with a major marketing campaign emphasizing its unique features. The company ensures that it is available in stores and online. They also set up a customer service team to handle any product issues or questions. 8. Post-launch evaluation and feedback. Objective: after the product has been launched, the team collects feedback and evaluates the product's performance in the market. This phase helps to identify any areas for improvement or future iterations. Example, after the smartphone is released, the company closely monitors customer reviews and sales data. If users report problems with battery life or performance issues, these insights may inform future product updates or the next model release. Conclusion: the product design process is a structured, iterative approach that requires collaboration between cross-functional teams, including designers, engineers, marketers, and manufacturers. By following a systematic process, companies can ensure that their products meet customer needs, are manufacturable at a reasonable cost, and are successful in the marketplace. Next important question is: discuss about the product and process design strategies. Product and process design strategies are essential for organizations to develop products that meet customer needs while ensuring efficiency and competitiveness in production. These strategies influence how a product is conceptualized, developed, manufactured, and delivered to the market. Product design refers to the creation and development of a product, while process design focuses on determining how the product will be manufactured. Product design strategies. Product design strategies are the methods and approaches used to create a product that fulfills market demands and achieves organizational goals, such as cost reduction, quality improvement, and market differentiation. There are several types of strategies that companies use when designing a product. 1. Top-down design strategy. Description: in the top-down design approach, the product design begins with a broad vision or concept. The product development process is driven by strategic goals set by senior management, who make decisions based on market needs, company capabilities, and available technologies. The design team then breaks down the high-level concepts into smaller components. Example, a company planning to launch a new electric vehicle, EV, might begin with a top-down strategy. Senior management would decide on the strategic goals, such as affordability, sustainability, and range. The product design team would then develop the car's architecture based on these goals, including the size, powertrain, and features. 2. Bottom-up design strategy. Description: the bottom-up strategy involves starting with the detailed design of individual components or parts. These are then integrated to form the final product. This strategy is more focused on utilizing existing technologies and components, and it's typically used in companies with a deep understanding of component technologies. Example, a smartphone manufacturer might use a bottom-up strategy by focusing on the design of individual components, such as the battery, screen, camera, and processor. Once each component is designed and tested, the team integrates these parts into a complete smartphone. 3. Concurrent engineering. Description: concurrent engineering is an approach where the design and development of the product are carried out simultaneously by different teams, example, engineering, marketing, and production teams. It emphasizes collaboration and communication between various departments to speed up the design process, reduce time to market, and improve product quality. Example, when designing a new laptop, engineering, marketing, and manufacturing teams work concurrently. Engineers design the hardware, while marketers gather customer feedback to ensure features meet consumer preferences. Meanwhile, production teams ensure that the design is feasible for mass production. This reduces development time and ensures that the product meets both customer and manufacturing requirements. 4. Design for manufacturing, DFM. Description: the design for manufacturing, DFM, strategy focuses on designing products that are easy and cost-effective to manufacture. The idea is to minimize production complexity and costs by considering manufacturing constraints and capabilities during the design phase. Example: a company designing a new plastic bottle may use DFM by simplifying the bottle shape to minimize the need for complex molds, choosing materials that are easy to process, and reducing the number of parts required for the bottle's cap and closure mechanism. 5. Design for assembly, DFA. Description: design for assembly, DFA, focuses on designing products in a way that makes them easy to assemble. The strategy aims to reduce the number of parts, simplify assembly steps, and lower assembly costs. Example: in the design of a consumer electronics product, such as a television, DFA might involve reducing the number of screws used in assembly, designing snap-fit joints for parts, and using standardized connectors, so that the assembly process is quicker and less costly. Process design strategies. Process design refers to the planning and development of the production process used to create the product. It encompasses selecting the appropriate manufacturing methods, processes, and technologies to efficiently produce the product while meeting quality standards and cost targets. Different process design strategies are used depending on the complexity of the product and the production environment. 1. Continuous process design. Description: continuous process design is used in industries where products are produced in large quantities and the production process is ongoing, such as in the chemical, oil, or food industries. This strategy is used when the product is uniform and produced in a continuous flow. Example: a company producing soft drinks might use continuous process design. The production lines would operate continuously to bottle the drinks, mixing ingredients in a precise process and ensuring consistent quality throughout the production. 2. Batch process design. Description: batch process design is used when products are produced in groups or batches rather than continuously. It is common in industries like pharmaceuticals, food processing, and small batch manufacturing. The product undergoes a series of steps in each batch, and production is typically halted and restarted between batches. Example: a bakery producing different varieties of bread might use a batch process design. The company would produce a batch of sourdough bread, then switch the equipment to bake a batch of whole wheat bread, optimizing each batch's production time and resources. 3. Flexible manufacturing system, FMS. Description: a flexible manufacturing system, FMS, is a process design strategy used in environments where a variety of products need to be produced with flexibility and quick changeover times. FMS is designed to adapt to changes in product types or designs with minimal downtime. Example: an automotive manufacturer might use FMS to produce different car models on the same production line. Machines can be reprogrammed to switch between various vehicle models without significant downtime, allowing for flexible production of different products. 4. Job shop production design. Description: job shop production is used for custom or low-volume production where each product or order is unique. This strategy is suitable for industries like metalworking, custom furniture, or specialized machinery. Example: A company that manufactures custom furniture may use a job shop design. Each piece of furniture is built to a customer's specific requirements, with different types of wood, sizes, and finishes. The production system needs to be flexible enough to accommodate these variations. Conclusion: both product design and process design are crucial to the successful creation and production of goods. Product design strategies, such as top-down design or design for manufacturability, focus on creating products that meet customer needs while optimizing costs. Process design strategies, such as continuous process design or flexible manufacturing systems, ensure that the manufacturing process can efficiently produce high-quality products. By choosing the right combination of these strategies, companies can create products that are cost-effective, meet market demands, and are manufacturable at scale. Next important question is: value engineering, VE, is a systematic method for improving the value of a product, service, or project by assessing its functions and finding ways to reduce cost while maintaining or improving its quality and performance. The main objective of value engineering is to ensure that the necessary functions of a product or service are achieved at the lowest possible cost, without compromising on quality or performance. Value engineering is often applied during the design and development stages of a product, but it can also be used during the production, operation, or maintenance phases. Phases of value engineering. The process of value engineering is typically carried out in 5 phases, which are: 1. Information phase. Objective: gather and analyze all relevant information about the project, product, or service to understand its current state and to define the scope of value engineering. Example: for a new construction project, during the information phase, the project team may collect details on the materials specified for construction, estimated costs, and the expected performance of the building. They would gather information about the requirements, such as durability, safety standards, and aesthetics, to identify areas where costs could be reduced without compromising quality. 2. Function analysis phase. Objective: analyze the functions of the product or service to understand the role of each component in fulfilling the overall objectives. The goal is to identify where value can be improved by changing, eliminating, or optimizing functions. Example: in designing a car, the function analysis phase might identify functions like transporting people, providing safety, and comfort. The analysis would then evaluate which features, example, heated seats, advanced infotainment systems, contribute significantly to these functions, helping the team to consider if any functions can be simplified or eliminated to reduce costs. 3. Creative phase. Objective: generate ideas and alternatives that can improve value by achieving the desired functions at a lower cost, or by providing additional functions at the same cost. Example: in the design of a bridge, engineers might brainstorm alternative materials such as using recycled steel instead of new steel to lower costs. They might also consider different construction methods, example, modular prefabricated sections, to reduce labor costs and speed up construction. 4. Evaluation phase. Objective: evaluate the ideas and alternatives generated in the creative phase to determine which ones are feasible and provide the most value in terms of cost savings and functionality. Example: for the same car project, the evaluation phase may involve comparing the cost of various alternative materials, example, plastic instead of metal for certain parts, and assessing whether the performance and durability of the car will still meet the desired standards. The team may also evaluate whether the alternative ideas align with safety regulations and customer preferences. 5. Implementation phase. Objective: select the best alternatives and develop a plan to implement them in the final design, ensuring that the improvements are applied effectively. Example: after selecting a material change for the car's interior components, using recycled plastic, the implementation phase would involve updating the design specifications, sourcing the new material, and making necessary changes to the production process. The team would also monitor the performance of the car to ensure that the new material meets safety and durability standards. Conclusion: value engineering is a powerful method for improving the cost-effectiveness and efficiency of products, services, and projects by focusing on their core functions and exploring alternative solutions. By following the structured phases of information gathering, function analysis, creativity, evaluation, and implementation, organizations can ensure that they deliver maximum value with minimal cost. Next important question is multi-facility location problem. The multi-facility location problem is a type of optimization problem where the goal is to determine the optimal locations for multiple facilities, such as factories, warehouse, or distribution centers, to minimize costs or maximize certain objectives, such as minimizing transportation costs or service time to customers. Basic structure of the multi-facility location problem. In a typical multi-facility location problem, there are several factors to consider. Customer demand, the number of customers or the amount of goods required at each location. Facility locations, the potential locations where facilities can be established. Costs associated with opening a facility, including fixed costs, transportation costs, or service delivery costs. Distances, the distance between potential facility locations and customers or between facilities themselves. Steps involved in the multi-facility location problem. The goal is usually to 1. Select the locations for the facilities. 2. Assign customers to the closest facilities or based on some other criterion, example, service level, capacity, etc. 3. Minimize the total cost, which could include opening costs for the facilities, transportation costs to deliver goods, or any other relevant cost. Conclusion: the multi-facility location problem is a classic optimization challenge that involves selecting the best locations for multiple facilities, assigning customers, and minimizing the associated costs. By modeling the problem with mathematical formulations and using optimization techniques, businesses can effectively address complex logistics and facility planning issues. The example above shows how such a problem can be approached using fixed costs, transportation costs, and customer demands. Next important question is: explain the classification of layout. The layout of a production facility refers to the arrangement of machines, workstations, and equipment within a plant to maximize efficiency, minimize cost, and optimize the workflow. Proper layout planning is essential for smooth production processes, improved communication, minimized material handling costs, and enhanced safety. Layout design is classified based on the type of production process, products, and the flow of materials. Here are the main types of layouts. 1. Process layout, functional layout. Description: in a process layout, similar processes or equipment are grouped together based on their functions. This layout is common in industries that produce a wide variety of products in small batches and where flexibility in production is required. Example: a job shop like a machine shop is a typical example of a process layout. For example, in a shop that manufactures custom metal parts, various types of machines, lathe, milling, drilling, are grouped in separate sections. Each part may require several different machines for different processes. 2. Product layout, line flow layout. Description: A product layout arranges workstations, equipment, and tools along the production line in a sequential order to support the continuous flow of products. This layout is used in mass production environments where a single type of product or a few similar products are manufactured in large volumes. Example: automobile assembly lines typically use a product layout. In an automobile factory, components like engines, chassis, and wheels are passed through a sequence of workstations, welding, painting, assembly, along a moving production line. 3. Cellular layout, group technology layout. Description: a cellular layout organizes workstations and machines into cells, each designed to produce a family of similar products. This layout uses the principles of group technology, where similar operations are performed on similar products in dedicated work cells. It combines the advantages of both process and product layouts. Example: a mobile phone manufacturing plant might use a cellular layout where cells are dedicated to producing different components like screens, batteries, and camera modules. Each cell has the machines needed for its specific components, allowing for faster production and more focused operations. 4. Fixed position layout. Description: a fixed position layout is used when the product being produced is large, heavy, or immobile. In this layout, the product remains stationary, and workers, equipment, and materials are brought to the product's location. It is commonly used in industries where complex, large products are made, such as construction, shipbuilding, and aircraft manufacturing. Example: the construction of a skyscraper or a ship is an example of a fixed position layout. Workers, materials, and equipment are brought to the construction site, where the building or ship is assembled in place. 5. Hybrid layout. Description: a hybrid layout combines features of the above layout types to suit specific production needs. A company may use different layouts for different parts of the production process or for different product lines. The hybrid approach provides greater flexibility and helps balance the strengths and weaknesses of various layouts. Example: a furniture manufacturing plant may use a hybrid layout. The plant might have a product layout for mass-producing chairs or tables, while employing a process layout for custom orders or smaller batch production of unique designs. 6. Retail layout. Description: retail layouts are designed to optimize the customer shopping experience. This layout focuses on the placement of shelves, aisles, and displays to encourage shopping behavior, maximize space utilization, and improve customer convenience. Example: in a supermarket, the layout typically has fresh produce near the entrance, followed by aisles that direct customers to high-demand items, with checkout counters at the end to encourage purchases along the way. Conclusion: choosing the right layout depends on factors such as production volume, product variety, and the need for flexibility. Each layout type has its advantages and is suited to specific production processes, and companies often choose or combine layouts based on their unique operational requirements. Next important question is: what is Group Technology Layout? Group Technology Layout, GT layout, is a production layout that groups similar products or parts into families based on their processing requirements and arranges machines in such a way that each group of products follows a similar manufacturing path. The goal of this layout is to streamline production, improve efficiency, and reduce material handling costs by organizing the production facility into cells dedicated to producing a specific family of products. The concept of group technology, GT, is based on the idea that similar parts can be produced using similar processes and, therefore, grouped together to minimize setup times, reduce inventory levels, and increase productivity. Example of group technology layout. Electronics manufacturing. In an electronics manufacturing plant that produces different types of circuit boards, the group technology approach might be used to group the boards into families based on similar manufacturing processes. For instance, Family A, simple circuit boards, example, single layer, low complexity. Family B, complex circuit boards, example, multi-layer with more components. The machines are then arranged into cells for each family, with each cell having the necessary equipment, example, soldering, testing, assembly, to produce the respective circuit boards. Cell 1, for the production of simple, single-layer circuit boards, which involves fewer steps like soldering, cutting, and testing. Cell 2, for more complex multi-layer circuit boards, which involve additional steps such as multi-layer stacking, more advanced soldering techniques, and precise testing. Each family's production is handled in a dedicated cell, leading to improved efficiency, reduced material handling, and faster throughput times. Conclusion. Group Technology Layout, GT, is an effective production system for companies that produce a variety of similar products in moderate to high volumes. It helps in reducing cycle time, improving material handling, minimizing work-in-progress inventory, and increasing overall productivity. The approach is particularly useful for industries like automotive, electronics, and machine parts manufacturing, where parts can be grouped based on similar production processes. However, the initial setup for creating dedicated production cells can be costly and complex, and the layout is most beneficial when parts exhibit common manufacturing requirements. Next important question is: explain Johnson's algorithm in detail. Johnson's algorithm. Johnson's algorithm is a method used to determine the optimal sequence for jobs when a two-machine flow shop system is involved. It is designed to minimize the total make span, the total time required to complete all jobs, in a manufacturing or processing environment. In a flow shop system, jobs pass through a set of machines in a fixed order. Johnson's algorithm is particularly useful when there are two machines that handle jobs sequentially, and the objective is to find the optimal order of processing these jobs. Conclusion. Johnson's algorithm provides an optimal solution for scheduling jobs in a two-machine flow shop system. By dividing the jobs into two groups, sorting them based on processing times, and sequencing them accordingly, the algorithm helps to minimize the total make span. This method is highly efficient when applied to a flow shop with two machines and a limited number of jobs. Next important question is: define scheduling and also explain different types of scheduling with suitable examples. Scheduling. Scheduling in production management refers to the process of planning and organizing the timing of tasks or activities to ensure that they are completed efficiently, on time, and in the proper sequence. It involves allocating resources, such as labor, machinery, and materials, to various tasks over a specified period. The primary objective of scheduling is to ensure smooth workflow, minimize idle time, reduce production delays, and optimize resource utilization. Effective scheduling is crucial for improving productivity, reducing lead times, meeting deadlines, and maintaining quality control in manufacturing, services, and various industries. Types of scheduling. Scheduling can be classified into several types based on factors like the type of production system, the complexity of tasks, and the resources available. Below are the main types of scheduling with examples. 1. Precedence-based scheduling. This type of scheduling is based on determining the order in which tasks should be performed based on the dependency or precedence between them. Tasks that depend on the completion of other tasks must be scheduled accordingly. Example: construction project. In a building construction project, the foundation must be completed before the walls can be erected, and the walls must be in place before the roof can be installed. The tasks are scheduled based on their precedence. 2. Job shop scheduling. In job shop scheduling, multiple jobs are processed on different machines in a job shop environment. This scheduling type is used when each job may have different processing requirements and follows different paths across machines. It aims to minimize processing time and resource utilization while maintaining job priority. Example: custom furniture manufacturing. A woodworker has multiple custom orders for different pieces of furniture. The scheduling needs to allocate machines, example, saws, drills, polishers, to each job according to their unique processing needs and priority. 3. Flow shop scheduling. Flow shop scheduling is used in environments where products follow a fixed, predefined sequence of operations across different machines. This scheduling type aims to minimize the make span, total processing time, and ensure a smooth flow of materials through the production process. Example: automobile assembly line. In a car manufacturing facility, each vehicle must go through a series of operations, example, painting, assembly, testing, on a set sequence of machines. Scheduling ensures that each vehicle is processed in the correct order without bottlenecks. 4. Batch scheduling. In batch scheduling, tasks are grouped into batches, and similar tasks are completed together. This type of scheduling is often used in industries that produce large quantities of the same or similar products, such as pharmaceuticals, food processing, and chemical industries. It helps improve efficiency by minimizing setup time between batches. Example: pharmaceutical manufacturing. In a pharmaceutical plant, medications are produced in large batches. Scheduling groups similar medications into batches, and each batch follows the same production process, such as mixing, molding, and packaging, without frequent changes in equipment setup. 5. Priority scheduling. Priority scheduling allocates resources to tasks based on their priority level. Tasks with higher priority are processed first, regardless of their arrival time. This type of scheduling is common in real-time systems or when dealing with urgent tasks. Example: hospital emergency room. In a hospital, patients in critical condition, example, heart attack, are prioritized over less urgent patients, example, minor injuries. Similarly, medical tasks like surgeries or tests are scheduled based on their severity and urgency. 6. Real-time scheduling. Real-time scheduling is used in environments where tasks must be completed within specific time constraints, such as systems with strict deadlines. It ensures that each task is executed at the correct time to meet deadlines without delay. Example: air traffic control systems. In air traffic control, planes must follow specific flight paths and schedules to avoid collisions and delays. Real-time scheduling is used to ensure that flights are managed efficiently and in accordance with time-sensitive constraints. 7. Forward scheduling. In forward scheduling, tasks are scheduled to start as soon as the resources are available. It focuses on completing jobs as quickly as possible and may result in a longer make span, as tasks may overlap or be completed in an order that is not optimal for resource utilization. Example: manufacturing of a product. In a factory, forward scheduling may dictate that production starts immediately after receiving an order, regardless of the current workload on machines or available resources. This is often used in high-demand environments where completing jobs as quickly as possible is important. 8. Backward scheduling. Backward scheduling works in the opposite way to forward scheduling. It starts by determining the final delivery or completion date and schedules tasks backward to identify when each task should start. This type of scheduling ensures that jobs are completed just in time to meet deadlines, minimizing work-in-progress inventory. Example: custom software development. A software company may set a delivery date for a new software product and then schedule tasks backward, determining when development, testing, and deployment should occur to ensure the product is ready by the target deadline. 9. Gantt chart scheduling. A Gantt chart is a visual scheduling tool that displays the start and end times of tasks in a bar chart format. It is useful for tracking the progress of multiple tasks and ensuring that they are completed on time. Gantt charts can show dependencies, overlap, and duration of tasks. Example: project management. A project manager uses a Gantt chart to schedule and track the various tasks involved in a construction project, including excavation, foundation work, and electrical installations. Each task is represented by a bar that spans its expected duration, and the dependencies between tasks are shown. 10. Resource-constrained scheduling. Resource-constrained scheduling focuses on allocating limited resources, such as machines, labor, and materials, in the most efficient way. It aims to ensure that all tasks are completed within the constraints of resource availability, avoiding bottlenecks and delays. Example: printing press. In a printing press, the scheduling system must allocate printing machines, labor, and raw materials in such a way that all orders are completed on time without exceeding resource limits. The system must balance demand for machines, labor shifts, and material supplies. Conclusion: effective scheduling is essential to ensuring that tasks are completed efficiently and resources are used optimally. The type of scheduling used will depend on the specific requirements of the production system, whether it's a job shop, flow shop, batch process, or service environment. Choosing the right type of scheduling can minimize delays, reduce costs, and improve overall productivity. Each scheduling method serves a specific purpose and is designed to address the challenges of different industries and production environments, ensuring that deadlines are met and resources are managed effectively. Next important question is: what is statistical quality control? Statistical quality control, SQC, is a set of statistical techniques used to monitor and control a process to ensure that it operates at its full potential to produce products that meet quality standards. SQC involves the application of statistical methods to measure and analyze the variability in production processes and products. The goal is to detect and address any variations from the desired performance or specifications, thereby ensuring product quality and consistency. SQC includes the use of control charts, process capability analysis, and other statistical tools to understand and control the variability in manufacturing processes. It is an essential component of quality management systems and is used in a wide range of industries, including manufacturing, services, and healthcare. Benefits of statistical quality control. 1. Early detection of problems. SQC tools like control charts help identify problems early in the production process, allowing corrective actions to be taken before large quantities of defective products are produced. 2. Reduced waste and rework. By maintaining consistent quality, SQC reduces the need for rework and minimizes waste, leading to cost savings. 3. Improved customer satisfaction. Consistent product quality leads to higher customer satisfaction, fewer complaints, and improved reputation in the market. 4. Continuous improvement. SQC encourages continuous monitoring and improvement of the production process, ensuring long-term sustainability and competitiveness. 5. Data-driven decision-making. SQC relies on objective data, helping decision-makers understand the root causes of issues and make informed decisions about process improvements. Conclusion. Statistical quality control is a powerful approach to ensuring the quality of products by using statistical methods to monitor and improve production processes. By detecting variations, identifying the root causes of defects, and implementing corrective actions, SQC helps organizations maintain high quality, reduce costs, and improve customer satisfaction. Whether it's in manufacturing, healthcare, or service industries, SQC plays a vital role in quality assurance. Next important question is: explain ABC technique of inventory control. ABC technique of inventory control. The ABC analysis is an inventory management technique based on the Pareto principle, 80-20 rule, which states that a small percentage of items, usually around 20%, are responsible for a large portion, around 80%, of the value or usage in inventory. In the context of inventory management, ABC analysis helps categorize inventory items into three classes, A, B, and C, based on their importance, value, or consumption rate. This classification allows companies to focus their efforts and resources on managing the most critical items, Class A, while less critical items, classes B and C, receive less attention and fewer resources. ABC categories. 1. Class A, high value or critical items. These are the most valuable items in the inventory, usually accounting for a small percentage of the total items, around 10 to 20%. They contribute to a large portion of the total inventory value, around 70 to 80%. These items are tightly controlled, closely monitored, and reordered frequently to prevent stockouts. Examples: expensive raw materials, high-end machinery parts, or top-selling products. 2. Class B, moderate value or important items. Items in this category are of moderate value and represent a middle range of both quantity and cost. They usually account for about 30% of the total items and contribute to approximately 15 to 20% of the inventory value. These items are managed with a less strict inventory policy than Class A but still require regular review and control. Examples: standard raw materials, mid-range products, or items with moderate sales. 3. Class C, low value or non-critical items. These are the least valuable items in the inventory, usually accounting for a large percentage of the total items, about 50 to 60%. They contribute to a small portion of the total inventory value, about 5 to 10%. These items require less frequent monitoring and ordering, often using a more lenient inventory policy. Examples: office supplies, small components, or low-demand products. Conclusion. The ABC analysis is a simple yet effective inventory control method that helps businesses prioritize inventory management based on the value and consumption rate of items. By classifying items into categories A, B, and C, companies can optimize their inventory practices, reduce unnecessary costs, and ensure they have the right materials in the right quantities at the right time. Next important question is: brief on components of integrated material management. Integrated material management, IMM, is the coordination and control of all activities related to materials, such as raw materials, components, and finished goods, to ensure that the right materials are available at the right time, in the right quantity, and at the right cost. IMM integrates various functions within an organization to optimize inventory, procurement, and distribution processes. The key components of integrated material management are 1. Materials planning and control. This involves forecasting, planning, and managing the procurement and distribution of materials to meet production needs. It includes activities like material requirement planning, MRP, bill of materials, POM, and demand forecasting. Example, a car manufacturer uses MRP to plan and control the purchase of raw materials like steel, plastics, and rubber based on production schedules. 2. Inventory management. This includes monitoring and controlling stock levels, ensuring that materials are available when needed without overstocking, which ties up capital and storage space. Techniques like ABC analysis, EOQ, economic order quantity, and JIT, just in time, are used to optimize inventory levels. Example, a retail store uses the ABC analysis to manage its stock of different types of goods, focusing on high-value items, Class A, and ensuring timely reordering of popular products. 3. Procurement management. Procurement involves purchasing materials from external suppliers. This function ensures that the right quantity of materials is acquired at the best price and delivered on time. It includes supplier selection, contract negotiation, and vendor management. Example, a manufacturing plant negotiates long-term contracts with suppliers for essential raw materials, ensuring that they receive bulk discounts and consistent supply. 4. Logistics and distribution. This component deals with the movement of materials from suppliers to warehouse and then from warehouse to the production or retail locations. It involves managing transportation, warehousing, and distribution networks to ensure timely delivery. Example, a food processing company coordinates with logistics providers to ensure that ingredients arrive at the factory on time and finished goods are distributed to retailers efficiently. 5. Quality control. Quality control ensures that the materials procured and used in production meet the required standards and specifications. It involves testing, inspection, and monitoring to avoid defects or deviations from quality standards. Example, a pharmaceutical company tests raw materials, such as active ingredients, to ensure they meet required specifications before they are used in drug production. 6. Supplier Relationship Management, SRM. SRM involves managing and optimizing relationships with suppliers to ensure reliable quality, cost-effectiveness, and timely delivery. It includes contract management, performance evaluation, and communication. Example, a company collaborates closely with its suppliers to ensure the timely delivery of high-quality parts and works with them to improve lead times and reduce costs. Conclusion. Integrated material management combines various functions such as planning, procurement, logistics, inventory control, and supplier relationship management to streamline the flow of materials, reduce costs, and improve overall efficiency. By integrating these components, organizations can ensure that materials are available when needed while minimizing waste and stockouts. Next important question is: write a note on purchase management and stores management. Purchase management. Purchase management is a critical function within an organization that involves procuring the necessary goods, services, and materials required for production, operations, and overall business functioning. It ensures that the right quality and quantity of materials are purchased at the best price, with timely delivery. The goal of purchase management is to maintain optimal inventory levels, ensure supply chain continuity, and manage supplier relationships effectively. Example of purchase management. In a furniture manufacturing company, the purchase department is responsible for procuring wood, nails, paint, and other components. The team might regularly analyze the supplier market, select vendors based on cost and delivery times, and negotiate contracts. They would then create purchase orders based on production needs and monitor inventory levels to avoid production delays. For instance, if the company is launching a new line of chairs, the purchase team ensures that high-quality wood is ordered well in advance to meet the production schedule. Stores management. Stores management refers to the management of materials and goods in a company's warehouse or storage facility. It involves receiving, storing, issuing, and controlling materials to ensure that they are available for production or other business operations when needed. Effective stores management reduces the risk of stockouts, excess inventory, and ensures the efficient utilization of storage space. Example of stores management. In a construction company, stores management is responsible for ensuring that raw materials such as cement, steel, and construction tools are always available at the site. When a new delivery of cement arrives, the stores team checks the delivery against the purchase order, inspects the quality, and stores it in the warehouse. The team keeps track of inventory levels and issues cement to the construction site when needed. They also ensure that materials like steel rods are stored properly to prevent rust and damage. Conclusion. Purchase management and stores management are two key components of the overall material management system in any organization. Purchase management focuses on sourcing and acquiring the necessary materials at the best price, while stores management ensures that these materials are stored efficiently and are readily available for production. By coordinating these functions effectively, companies can maintain smooth operations, minimize costs, and ensure the timely availability of materials.